In this lesson, we're going to examine our second set of word problems, ones that don't have a given equation and instead we have to build one ourselves. Yeah, the same rules usually apply when we want to solve these things. We want to be able to set up an equation, we want to make it equal to 0, standard form, and if we can factor it, and then use, or if not, use a quadratic formula. Also with word problems, don't forget let statements and therefores. So let's take a look at the first one. It's just examples today. The sum of the squares of two consecutive integers is 113. Find the integers. So what do I not know? I don't know the integers. So I'm going to say x is the first integer. Okay. But what do I know about the second integer? I know it's consecutive, which means it's after the first integer. In fact, oops, that's not how I spell integer. In fact, it's one bigger than the previous one. That's what consecutive means, right? 2, 3, 4. The next one's always one bigger. So I can take x and add 1 to it, and I have my second integer. There's my two let statements. Okay, the sum of the squares. Well, sum means add. Squares means you have to square something. So if I sum and squares these integers, I'll end up with the first one squared plus the second one squared. And I know it is 113, which means equals 113. And I have myself a quadratic equation that can be solved now. How do I solve this? Well, I'm going to make it equal to 0, and I'm going to put it in standard form, which means I need to get rid of my brackets. So brackets squared means write it out twice. I also want to make it equal to 0, so I'm going to bring the 113 over to the left. I'm going to do some FOIL. Okay. And then I'm going to collect all my like terms. So I end up with 2x squared, 2x's, and minus 112. It's ready to be solved now. All that math process was to get me in a position where I can solve this equation. To solve it, let's try factor. So I notice these are common factor. And I also notice that I have a simple trinomial. So I can multiply negative 56 and add to 1. And there's definitely numbers that do that. Positive 8 and negative 7 do that. There's also actually one more hint that this can be factorable. The fact that we have integers. Integers means we have whole numbers. If there's whole numbers, they have to be factorable. So what are the answers? The answers are negative 8 and positive 7. And both of these answers are admissible. If x is negative 8, and I go back to my let statements, then x plus 1 is negative 7. Or if x is 7, then x plus 1 is 8. So when I do my therefore, I have to make both lists, or write down both sets. Okay, so the integers are choice number 1, negative 8 and negative 7, or choice number 2, 7, 8. Those are both consecutive. Then when I square them and add them, I get 112. All right, there's the first one. I'm going to get you guys to try the second one. So pause it, see if you can figure out this one. Okay, similar style, just different question. The sum of the squares of 3 consecutive odd integers is 1595. Find the integers. Okay, so x is going to be my first integer. And what's my second integer going to be? Well, if it's consecutive and odd, there's a key word. Okay, let's think about that for a second. Consecutive and odd. So for example, 3, and the next odd integer would be 5, and then 7, and then so on. The difference between these is always 2. So in other words, I have to go x plus 2. There's also 3 consecutive integers this time, so the third integer, how do we get from 3 to 7? I add 4. Once you have the let statements, however, the question remains the same as the previous ones. Our equation, x squared, x plus 2 squared. I want to sum all the squares, right? X plus 4 squared, and that comes out to 1595. The math is the same style now. Let's get rid of those brackets by writing them out twice, and then foiling. I want to make it equal to 0, so I'm going to bring the 1595 to the left. Okay, let's do the FOIL. So x squared, 2x, 2x, and 4. x squared 4x, 4x, and 16, minus the 1595 still, equals 0. If we collect them up this time, we get 3x squared, we get 12x's, and we get minus 1575. Okay, now I know it's going to be factorable again because the question said integers. There's going to be bigger numbers this time, but it's still factorable. So let's common factor first to make it smaller. I need to think of man, things that multiply to negative 525 and yet add to 4. And I know they're actually 4 digits apart. And the fact that this is a 4 and this is a negative tells me that. Okay, so if I try this, think of things that are 4 digits apart. I don't know, we could try, and remember they're odd. So what can we think of odd things that are 4 digits apart? We could try like 17 and 21, or 19 and 23, or 21 and 25. That'll work. X plus 25, x minus 21. So my zeros are negative 25 and positive 21. So if I go back to my let statements, I could have x being negative 25, which would make x plus 2 be negative 23, and x plus 4 be negative 21. Or x could be 21, which makes x plus 2 23, and x plus 4 25. So my therefore is the integers are choices, number 1, negative 21, negative 23, negative 25, or 21, 23, 25. I didn't say this would be positive or negative. We have both options. I'll try the next one. 2 integers differ by 8, and the sum of their squares is 130. So nothing about consecutive this time, nothing about even or odd. We just know they differ by 8. So that's that x equals the first one. Well, the next one has to be 8 different than that. So one of the choices I could have is x plus 8. That could be my second integer. Or if you had chosen, you could have made this x minus 8. That will also work. It'll get you the exact same answer. It's your choice which one you want to do. Again, we have the sum of the squares. So we're going to square them and add them. And we know it comes up to 130. And this kind of looks like the same old question again. And hopefully we've got the hang of these ones by now. So we're going to do FOIL, make it equal 0, collect some like terms. And we end up with 2x squared, 16x's, and minus 66. And we know it's factorable because we're dealing with integers again. We just got to figure out what those integers are. What multiplies and adds in this case? Well, x plus 11 and x minus 3 will work. So our answers are negative 11 and positive 3. So to go back to the let statements, if x is negative 11, then x plus 8 makes negative 3. Or if x is 3, then x plus 8 comes out to 11. Okay, so I need my therefore. The integers are negative 11 and negative 3, or 3 and 11. And the whole thing about squaring them gets rid of that sign every time. Okay, so there's some number problems. Pretty easy to set up in general. Let's talk about some shape ones. Let's start with a nice simple one. The rectangle is 4 meters longer than it's wide. The area is 192. Find the dimensions of the rectangle. So if we draw a rectangle, we know it's 4 meters longer than its width. So if we make x the width, the length has to be 4 more than that. So I got to add 4. We also know that areas are found by length times width. We know the area, it's 192, and our length and our width are x, and x plus 4. Well, that looks almost like a quadratic already. I can make it equal to 0. I can expand my brackets and bring the 192 over, And I got my quadratic pretty quickly that time. Okay, let's try factoring. Let's think of things that multiply to 192, negative 192. Add to 4, so they're 4 digits apart. What works for that? 16 and negative 12. That'll work. So I got negative 16 and I got positive 12 for my answers. Now when we deal with shape questions, we often come across something that's inadmissible. In this case, negative 16. We can't have a length or a width, for that matter, that has a negative value. That's not possible. Okay, so x has to be 12. And if x is 12, then x plus 4 has to be 16. Okay, so the dimensions of the rectangle is 12 meters by 16 meters. And it's, again, when you deal with shape questions, get used to seeing things that are inadmissible. That's going to happen with shape ones. All right, last one. There may be times where two variables are not directly related. Okay? If that's the case, like we did with optimal values way back when, we had two different variables. Sometimes you're going to have to deal with that. That means you're going to have to make two different equations. But if you can, try to make an equation that only deals with one variable. Try to avoid using x's and y's if you can. If you can't, well, then you have to do it. But if you can, try to. So if we look at this last example, a right triangle has a hypotenuse of 10. So let's think about that. A right triangle, right hypotenuse. If one of the sides is 2 meters longer than the other, find the dimensions of the triangle. So it'd be really easy to think about this as being x and y. Okay. That would be easy to think of it that way because two different sides. And it tells us that one of the sides is 2 meters longer than the other. So if you would, y is going to be x plus 2. It's 2 meters longer than the other. But I think it makes more sense rather than trying to use x's and y's. And there's nothing wrong with doing x and y's. But to take this, and instead of doing it that way, to go back to the question and say, oh, this is actually just x plus 2. Try to avoid making two variables. Take the relationship that you're given the question and try to make it into a single variable. Okay. Find the dimensions of the triangle. Okay, so I've got to find the dimensions. What do I know about triangles? Hypotenuses. I know that if I'm talking about the lengths of the sides of them, I can use Pythagoras. A squared plus b squared equals c squared, where c is the hypotenuse. So in our case, x squared plus x plus 2 squared equals 10 squared. And this looks suspiciously like the sum of the squares of two integers, does it not? Which means I can solve it in the same way. I can get rid of my brackets by doing FOIL, and I can bring it over and make it equal 0. So let's do that. We'll do our FOIL. 10 squared is just the number 100, makes it easier to work with. If I collect my like terms, I get an equation equal to 0 in standard form. I can try factoring this. Okay, if I do that, I get a trinomial. I need to multiply a negative 48 and add to 2. So it's got to be 2 digits apart. Well, I know numbers that do that. They're positive 8 and negative 6. So my answers are either negative 8 or positive 6. Again, we're talking about dimensions here. So this is inadmissible, which means the answers have to be x is 6 and x plus 2 is 8. Therefore, the dimensions or the triangle has sides of 6, 8, and the original one that we knew, 10 meters. Okay, that's the end of that lesson. And just some questions to practice today and give yourself a chance to try some. They're on a handout. Get the answers on the website. So you can try those. If you get stuck with some things, come see me.